So the first one was pretty easy, so now let's do a medium one. Here we have the sum from n equals 1 to infinity of negative 1 to the power of n times ln n over square root n. Now we know that this is an alternating series because of the negative 1 to the power of n, and thus we must use the alternating series test. Now the alternating series test has two conditions. The function must be decreasing for a certain x, and the limit as n approaches infinity of the function must equal 0. The function being b of n. So let's figure out where it is decreasing. Now we have b sub n is equal to ln n over square root n. Now we can't tell right away that this is a decreasing function for x of any number. So we must do the derivative. So we have ln x over square root x prime, which is equal to, let's see, 2 minus ln of x over 2 times x to the power of 3 over 2. So here we see that it is decreasing for 2 minus ln of x less than 0, the numerator. And so we get negative ln of x less than negative 2, multiplied by negative 1 or divide. We get ln of x greater than 2, and now we take e to the power of ln of x and e to the power of 2, and we get x is greater than e squared. So this is where it is decreasing for all x greater than e squared. Now we have the second condition, which said that the limit of the function b of n as n approaches infinity must equal to 0. So we have to also test that one. So for that, we have the limit as n approaches infinity of ln of n over square root n. Now once again here you get infinity over infinity, which means that you must use L'Hopital's. Very rarely does this happen, but it's kind of fun when it does. So we get the limit as n approaches infinity of 1 over n over 1 over 2 square root n, I believe. Okay, so then this equals the limit as n approaches infinity of 2 square root n over n, which equals, once more, the limit as n approaches infinity of 2 over square root n. Now here we can obviously see that we get 0, because 2 divided by square root of infinity, which is still infinity, is equal to 0. Now this means that the series is convergent by the alternating series test.